Now we're going to take a look at our not logic, our nands and our knowers, and our not logic. So here we go. PB1 and PB2 turns on the light, PB3 turns off the light. So to make this simple, we're going to make a big AND turning on light 1. And it's going to be PB1 and PB2 turns that on, because if I did this, that would push a 1 and a 1 there. Okay? And then it says PB3 turns off the light. So if I put a not right here with PB3, let's see what we've got. Remember, this naturally returns a 1 because it's inverted, and so when I'm not pushing the button, I've got a 1, and these are zeros here. So when I push this button, I get a 1, and 2, I get a 1, and that's already a 1. The light will come on. When I push the button, because it's not, that's when it becomes 0. And for an AND, a 1, 1, 0 would return to 0. My next one here is PB1 and PB2 turns on the light. PB3 and PB4 turns off the light. So once again, we'll start with a big AND here, turning on light 1. And I'm going to have PB1 and PB2 turning this on. But now I would need another 1 here that we will be turning off with 3 and 4. So I'm going to use a NAND right here. Okay. And I'm going to put PB3 and PB4. So once again, this, because it's inverted, returns a 1, and it states change it, and these are zeros. So if I push PB1, I'd get a 1. PB2, I'd get a 1. If I get all the 1s across an AND, I would have a light. But the way that NAND works is if I push PB3 and PB4, this would become a 0, and it would go off.